Binary operation. Number of binary operations on a finite set. Commutative, associative and distributive binary operations. Arithmetic and logic operations are pivotal in developing computer programming. And, or, not. These are the fundamental logic operations. Let us study the fundamental properties of binary operations. An operation is a process which produces a new element from two given elements. For example, addition, subtraction, multiplication, and division of numbers. If the new element belongs to the same set to which the two given elements belong, the operation is called a binary operation. Definition: a binary operation or binary composition denoted by star or dot circle on a non-empty set A is a mapping with associates with each ordered pair A, B belongs to A cross A. A unique element to be denoted by A star B of A. Thus, a binary operation star on A is a mapping. Star maps from A cross A to A. Defined by star of order pair A, B belongs to A. Example: addition plus as well as multiplication into a binary operation on the set's natural number set N, integer set Z, rational number set Q, real number set R, and complex number set C. Multiplication is not a binary operation on the set of irrationals. For root 3 into root 3 equals to 3, 3 does not belong to Q dash. Whereas root 3 belongs to irrational number set Q dash. Similarly, subtraction or minus is not a binary operation on N. Also, division is not a binary operation on Z. The division on R0, that is, non-zero set of real numbers, can be defined as division maps from R0 cross R0 tends to R0. By the rule division of order pair equals to A division B. Clearly, division is a binary operation on R0. Number of binary operations on a finite set. We know that the number of functions from A to B is n of B power n of A. Let A be a finite set containing m elements. Since a binary operations on set A is a function from A cross A to A, number of binary operations on A equal to n of A power n of A cross A equal to m power m square. Example: let A equals to set of 1, 2, then n of A equals to 2. Therefore, number of binary operations on A equals to 2 power 2 square equals to 16. Commutative binary operation. A binary operation star on a set S is said to be commutative if A star B equals to B star A for all A, B belongs to S. Example: the binary operations addition, plus, and multiplication or into are commutative binary operation on Z. However, the binary operation subtraction or minus is not a commutative binary operation on Z, as 2 minus 1 not equals to 1 minus 2. Associative binary operation. A binary operation star on a set S is said to be an associative binary operation if A star B star C equals to A star of B star C for all A, B, C belongs to S. Example: the binary operations of addition or plus and multiplication or into are associative binary operations on Z. However, the binary operation subtraction or minus is not an associative binary operation on Z, as 2 minus 3 of minus 5 not equals to 2 minus of 3 minus 5. Distributive binary operation. Let S be a non-empty set. Star and dot circle be two binary operations on S. Then star is said to be distributive over dot circle if A star of B dot circle C equals to A star B dot circle A star C and B dot circle C of star A equals to B star A dot circle C star A for all A, B, C belongs to S. Example: the binary operation multiplication or into on Z is distributive over the binary operation addition or plus on Z because A into B plus C equals to A into B plus A into C, and B plus C into A equals to B into A plus C into A for all A, B, C belongs to integer number set Z. However, addition or plus is not distributive over multiplication or into because 2 plus 3 into 5 not equals to 2 plus 3 into 2 plus 5.